Good morning. This is Team Games for All, and welcome to our final presentation. These are the team members. Instructor is Heather, and we also have two professionals in accessible game design from the EA Positive Play group as our consultants. So let us start with an overview of our project. Our goal is to explore accessible game design patterns to push the boundaries of how people with disabilities can play different types of games in more accessible and challenging ways. Then comes a very natural question. What is the definition of accessibility? Or what is accessibility in games? Perhaps the following metaphor could help us better understand this topic. Imagine there are three people trying to see the view through this window, and it's our job to make that happen. And from the picture, it's clear that the window is simply too high for all of them, so an easy solution would be to give them 3 pairs of letters so they can stand taller like this. But something is still not right here. The ladder might be perfect for the person on the right, but not so much for the other two. So a better solution would be to give each of them a different length of ladder according to their height, so that they can all reach to the window at a proper height. In other words, accessibility is not about providing a universal solution that solves everything, but more about tailoring your experience to cater every specific situation. We then researched on the accessibility settings in current games, and some problems that we noticed includes that the accessibility settings are buried deep within in the hierarchy of game menus, and some games have the feature of letting players to map the button themselves, but the process is often tedious, especially for players with disabilities. And so the current process of accessibility settings fall into the following loop. The player plays a game and try the control first. If it doesn't feel right, they'll have to go back to the menu, find the corresponding function, map it to another button, and try again until it feels right. What we want to achieve, however, is to provide the players with a personalized gameplay experience, and we want to do it in a seamless way. With that, here are the two solutions that we present. The first one focuses on adaptively adjusting the accessibility settings for the players, while the second one aims to smooth the button mapping process and by embedding it into the game tutorial.
Thanks, Jerry. So for this part, I'll go over the exploration process through the semester and also uncover why we made the design decision. We start our primary research by visiting Intermediate Unit 1, a local public school. They offer multiple disability support classroom, and John Balash helped us to connect with the school. Also, we talked to some experts in accessibility design at HCI. For example, Dr. Patrick Carrington and also PhD candidate Franklin Lee. And we invite our participant come to our project room, play test our game, and we conduct several interviews with her. And we have her test and try different game controllers. What do we found? Actually, the people with motor mobility disability, they have super diversified disability situation. So it is hard and almost impossible for us to focus on how to categorize people through the semester, and it's actually inappropriate for us to categorize human beings according to their disability. So the challenge is how to design the same game for such a diversified group of people and bring them ideal experience. Refer back to the idea of accessibility. Actually, we want to customize, personalize, and tailor their game experience and control. But come to the real situation is that they are using all different type of hardwares. Maybe some adaptive controller or some gaming kit, or maybe Sip and Puff use their breath to control. So given the situation that we cannot regulate their gaming hardware settings, how to customize and tailor their game experience. Think about the metaphor of ladder. When you are designing a ladder for different people, actually the first step is trying to get their heights so that you can tailor the assistant tool for them. Similar in our case, we actually prioritizing how to getting user profile and information as the first step. For next part, I'll invite Dennis and Nielsen talk more about our design details and how we focus on our concept.
Thank you. So here comes the prototype and evaluation part. And our first prototype is about adaptive accessibility settings. It's a first-person railway shooter game. So here's the demonstration video. So this is the art style of our prototype. We mainly focus on using low poly models in a Western carnival scene. And how does it work? So first, we collect data in calibration level, and we run an algorithm to evaluate the performance score. Then the game is automatically set to a corresponding difficulty level according to the performance score. Moreover, in each stop, we will also tune the accessible setting based on players' performance. And this is the logic pipeline graph shows how we can achieve our final result. Sometimes difficulty is naturally a part of the game. We use the personalized profile to predict the barriers. The system will adjust the size, moving speed, and lifetime of the targets, as well as the aim assist level to match the best difficulty level according to player's profile. And according to this system, here comes two keywords, personalized and seamless. Personalized means each player gets their own profile, which will lead to a unique and personalized experience. Seamless stands for the settings is automatically implemented, so there is no back and forth, and it also means the automatic adjustment happens in the back end, so the player is still in the game without knowing anything happens behind. After we collecting all feedbacks from playtest, the major iteration we made is giving players the choice of turning on or off adaptive difficulty. And we also added aim assist as another accessibility tool, which can benefit players with tremors in their hands. We conducted multiple playtests and used NASA TLX method to measure the subjective workload of our playtesters. Most of our playtester has the result of score around 4 to 6 in a range of 7, which demonstrate that our adaptive difficulty fits their ability level.
Our second prototype is a platformer with automatic button mapping, which holds this genre because it requires more complex control and it usually requires the player to be more precise with their actions. And our playtester Jen mentioned several times that she seldom plays this genre because it is simply too difficult for her with her current setup. So we designed this prototype with automatic button mapping in hope that this system can help the player with a wide range of control scheme to map their controls according to their unique individual situations and be less frustrating in that process. So the game is very simple. It only has 3 controls. One is a directional control, which can be an analog stick or a D-pad, and the other 2 are user-defined keys. With these 3 input, we are able to design a moveset that is simple enough that can accommodate all kind of control scheme, yet complicated enough for those who are seeking for a little bit extra challenge because they can come up with some advanced combos to get to certain unreachable locations. And here is our button mapping process. To start, we have a task assigned to the players, which asks them to move around the tutorial scene with the analog stick. This teaches them that they need to read the task and then complete the task before moving to the next step and get them acquainted with the mapping flow. And then we start by mapping the jumping button. It starts also by giving a task for the player, and that also prompts the player to pick the button for the jumping action. And then the player can actually pick what button they want to use for that jumping action. They can experiment with a variety of buttons before they make a decision. And once they make a decision, they have to repeat that same button several times as a consent for the game to actually map that button with that action. And then after repeating several times, the button is mapped by the game. And the same flow is repeated for the electricity key as well. So here is a video showing our automatic button mapping process. So after playtesting and gathering some feedback from faculty members, we also made some improvement to our design. First, we changed the in-game text. The action referred to what the player should do in the game to the actual button they need to push. So that is easier to understand and more straightforward because they don't have to do the translation in the head. And also, since our game requests the player to press the electricity key and the jump key at the same time in multiple occasions, and we found that some players map the electricity key in a very awkward location that it cannot be pushed together with the jump key. So we also get some information from our faculty consultant, Tom, that we need to give the player more information about what to expect to prevent this kind of problem. So we also added that information in our text to solve that problem. We also added a remap menu in our game so that the player can change their button mapping setting if they're not satisfied with it. We also have a test feature in the game, in the menu, so that they can be transferred to a very safe location to test their adjustment out before returning to the game. So they don't need to worry about making mistakes or breaking the game flow. So we received mixed review from this design. For player with disability, we received very positive result generally, but for players who don't have disabilities, we have mixed opinions, but over 67% of those players agree that our system is not too complex for them. Here is some feedback from our playtester, Jan.
I really like the additional program for easily setting up custom buttons for a control. That is something that is often forgotten or poorly implemented. And in this case, it was very easy to set up, very quick. It really worked well. I enjoyed it, and I hope that more games can implement features like this in the future. I really like the additional program for easily setting up custom.
Okay, so for our deliverables, since we're an exploratory project, our deliverable are 2 game demos with the evaluation dataset, the documentation of proposals, and then accessible on a game design framework. The next part is the retrospective. So the first challenge we faced was it was really hard to find playtesters with upper body disabilities and to get access to the assistive technology hardwares like SIP and PUF. So what we did to address the problem is we focused on a specific player case, and we resorted to playtesting with non-disabled players with the adaptive controller that we had. And our second challenge was that accessibility in gaming is an emergent field without a clear structure. So we've been reading a lot of research papers, asking experts and try to get access to all kinds of online resources, and we also wrote a literature review. And then we tried to emphasize with our target audience by playing games using an adaptive controller with only one hand. Admittedly, it is not as useful, but since we need to incorporate the feedback of a real disabled player, but it did help with understanding accessibility. So one of the lessons learned is designing, implementing, and testing accessible features are really time and resource intensive. But however, the demand is growing big, and other players can certainly benefit from those accessible features. So that is our presentation. Thank you. We're open for questions.
So is the goal to kind of explore a generalized approach for accessibility, or to take some of your findings as inspiration to a very specific game, and how did that influence your approach in general to this project?
Yeah, so actually when we're designing to explore a specific game, or we trying to kind of summarize a framework for the game, actually our team picked the direction of maybe trying to work on some generalized workflow and trying to kind of expand the kind of framework to many other different games. And we see some potential of our demos that the design concept behind them can be used for many other different genre or different part of the game. Yeah. Yeah, thank you.
Given that answer, how extensible is the button mapping? Because the game kind of had a simple set of buttons to begin with, so like how far do you think you can push that?
Yeah, I think the idea behind the button mapping is, so first, like, we can almost assume that all players with disabilities have to somehow remap their buttons because they're set in a default controller like map out, and then they have like different setups that doesn't necessarily work with that. So the button mapping process that we designed is actually just blending the button mapping process with the actual gameplay, so they can get instant feedback. For example, if like a player, if the game doesn't have button mapping at all, which is terrible, they have to rewire all their hardware just for the game to work. And if the game has button mapping in a menu, then they have to go into the menu and then like make some adjustment and go back to the game, test it out, repeat for several times, which it's like a very frustrating process that players don't have disabilities don't necessarily have to face. So our idea is just to simplify this process, because like blending the button mapping process with actual gameplay can give you instant feedback about what your adjustment affect and then how is the button reacting to your body. So this is like our core idea, instead of like having to apply it to a specific genre or a specific game.
Yeah, the core idea is we're collecting data to build a player's profile so that the game adjusts to this profile. So button mapping is one module, and another module is to automatic adjust the accessibility options for you. And we can extend this to many others, like for people with visual impairment or hearing impairment. That's something we didn't do in our exploration, but it's certainly worth it for other people to maybe do some research about the topic.
I'm curious, for your deliverables, like what you created, who do you imagine would use them? Like who's your audience for that? And how do you think they would use what you've documented and learned?
So I guess for the final deliverable, because we have the demo, actually we were working with EA Positive Group, and they are interested in our projects and work closely with us, especially the evaluation parts of the game demos, and we will have the data passed to them. And also the game demos, the design framework is, I guess, our hope is that we want some game companies to see this kind of thing, to care about accessibility in game, because there are a huge market for the people with disability, and also it is worthwhile for designing these features can benefit more players instead of only the subgroup of players.
We also put, thank you. We also put our findings and some of the resources on our website so that other game designer can go through all of those, which was shared from HCI and the EA Positive Group with us.
All right, thanks, Steve.
Thank you.